In the year 1900, explorers navigating the deep freeze of northeastern Siberia shattered the permafrost and uncovered something massive. Beneath layers of ancient ice, they found dark, thick fur still attached to the hide of a titan. The Borisova mammoth was found in a posture of sudden collapse. Scientists examining the specimen found unchewed wildflowers and grasses still lodged in its mouth. The freezing process was so rapid that the creature was preserved mid-meal before it could finish swallowing. This was Mammuthus primigenius, the woolly mammoth. Standing 10 feet tall and weighing 6 tons, it survived the bitter cold using dense layers of insulating fat and a long, shaggy coat of hair. These were biological tanks, engineered for the extremes of the Pleistocene. Yet despite their physical power, they were erased from the mainland in a few thousand years, leaving behind only these perfectly frozen snapshots in the deep ice. Mammoths were the active engineers of their environment. By knocking down trees and grazing on shrubs, they prevented forests from taking over the high latitudes. This constant disturbance maintained the mammoth steppe, a vast, highly productive grassland that stretched across the top of the world. Early humans relied on these giants for more than food. Our ancestors scavenged their remains to build the world's first permanent structures, using massive rib cages and interlocking tusks as foundations. About 10,000 years ago, the empire began to fracture. A warming global climate turned the dry steppe into wet, mossy tundra, while the rise of efficient human hunting groups put relentless pressure on the remaining herds. When the mammoths vanished, the system for clearing saplings failed. Without their constant trampling, forests grew unchecked, replacing the reflective grasslands with dark canopies that absorbed more solar heat. The disappearance of the mammoth accelerated the warming of the Arctic. While the mainland herds perished, a small pocket of survivors escaped to Wrangel Island, outliving their cousins by 6,000 years. But the island was a trap. Rising sea levels eventually cut the connection to the mainland, leaving the population marooned. On this tiny landmass, the remaining mammoths were forced into generations of inescapable inbreeding. Their genetic lineage narrowed into a fatal bottleneck. With no new DNA, harmful mutations accumulated. A mutation in the FOXQ1 gene caused their insulating hair to become translucent, turning vital, shaggy coats into a useless fringe against the freezing wind. The final blow came when a freak weather event or drought destroyed the island's freshwater supply. For thirsty survivors already weakened by genetic decay, the lack of fresh water was a terminal event. Their extinction was a slow, claustrophobic tragedy. They weren't killed by a single catastrophe, but by the weight of their own deteriorating DNA and the rising sea around them. Modern science is now attempting to reverse that decay. By analyzing weathered remains preserved in the permafrost, researchers are recovering the code of the mammoth, looking for the specific instructions that once made them cold-resistant. Colossal Biosciences intends to use CRISPR to splice these ancient sequences into the genome of the Asian elephant. The goal is to create a genetic proxy, an animal that looks and acts like a mammoth, even if it is built from modern elephant DNA. The plan relies on a specific mechanic. In winter, heavy mammoths trample through deep snow to find food. By compressing the snow, they remove its insulating effect, allowing the deep frost to penetrate further into the ground. This keeps the permafrost, and the greenhouse gases trapped within it, safely frozen. We have moved past observing these animals. Now, we are attempting to deploy them as functional climate technology. We aren't just studying the past, we are trying to recruit it. But the science creates a difficult bioethical problem. Mammoths were intelligent, social creatures. If a proxy mammoth is born into a melting world, it will have no mother and no ancestral herd to teach it the complex social behaviors required for survival. We are proposing a high-tech solution to fix our own environmental errors, yet we may be imposing a new kind of isolation on a creature that already suffered through thousands of years of geographic imprisonment and decay. As we edit the code of life to stabilize our climate, we have to consider what is actually being born. If we resurrect the body of the mammoth to serve as a tool, are we bringing back its soul, or just a shadow?